Hi guys, how is it going? Welcome back to my channel. If you're new here, my name is Nastasia and I'm a hardware engineer. In this video, I will be talking about my top 5 programming languages to learn in 2021 for hardware engineers and electrical engineers. I receive a lot of questions from you guys asking which programming language to pick and to study, which language is in the high demand right now. Should you study System Verilog or VHDL? Should you study C or C++ or maybe Python or maybe Specman? I will try to address all of these questions in this video. Coding is something certainly associated with software development. However, just trust me, you cannot survive and prosper in hardware world without coding skills. So today I would like to share with you my top 5 programming languages for hardware engineers and electrical engineers, and this rating will be based on 3 factors: the today's popularity of the language, the outlook for the future, and the job opportunities. So let's dive into it. The number 5 in my list is Verilog. Verilog is a hardware description language which is used to describe the behavior and structure of electronic circuits, mostly digital circuits. So basically coding with Verilog is what we call digital design nowadays. Verilog was created back in 1984, so about 40 years ago, and it's based on C and other programming languages, so its syntax actually is similar to C. Verilog nowadays is used to describe any hardware or digital system such as a microprocessor or a memory, and what is important, it can be used to describe it at different abstraction levels: at behavior level, register transfer level, and at gate level. For instance, you can describe a behavior of some analog oscillator or video DSP, and then it can be synthesized in hardware. Or you can just download some Verilog code of our microprocessor and then implement it in FPGA or in silicon. Now I can foresee that you have a question: why Verilog and why not VHDL? What I see happening in industry nowadays is that VHDL is getting obsolete and it's being replaced by Verilog, and even the EDA2 vendors, they do not support VHDL related bugs anymore, so their R&D is only focused on Verilog related development. And this trend is happening for the last 10 years and will go on. And I will provide some quite interesting statistics I found on this, but just a little bit later in this video. I would say the only application where VHDL is still commonly used is FPGA design and design for aerospace and defense applications, but this is only a tiny fraction of the whole electronic circuit market, and the rest is definitely dominated by Verilog. Number 4 in my list is an enhanced version of Verilog called System Verilog. System Verilog first time appeared 2 decades ago, and it was designed by Synopsys as an evolution of the Verilog language. System Verilog acts as a superset of the Verilog 2005 version and a lot of extension to it, and it contains also some features of C and VHDL languages. And System Verilog is a hardware description language as well as a hardware verification language, which means it is HDVL. So System Verilog is a unique language which can be used to describe the behavior of the hardware as well as to verify it, so this is the beauty of it. System Verilog is widely used in semiconductor industry and in hardware design industry in large companies like AMD, Intel, Qualcomm, Nvidia. For instance, the digital design and verification and modeling of a complex SoC such as an Apple's M1 chip can be carried out in System Verilog. How cool is that? And now I found a very cool analysis done by Siemens about the industrial language trends. So you can see the trend here. The first bars reflects the popularity of the language like 10 years ago. The third bar shows its usage in 2020, and the last bright blue bar reflects the future projection. At first, one can clearly see that Verilog is the most adapted language. What is interesting that in the last years VHDL and Verilog are decaying and System Verilog is picking up. This chart is actually nicely illustrates, or let's say confirms, why I didn't include VHDL in my list today. Now let's have a look on the second chart, which shows the verification trends. We can see that the most used language nowadays is System Verilog. It's used like in 80% of all designs. The next two languages here are C and Verilog, while you can see that VHDL and Specman are very rarely used. So in case you're now deciding in which programming language invest your time in order to be in high demand on the job market, you should definitely consider System Verilog. It will be certainly in high demand for hardware design, modeling and verification for the next decades. The number 3 in my list is, surprise, surprise, MATLAB. MATLAB is a high-level programming language which comes with its own EDA, so Integrated Design Environment, and a huge set of libraries. MATLAB was created in 80s by mathematician and programmer Clément Malher. His goal was to find an alternative way for his students to perform linear algebra and numerical computations without using Fortran. And MATLAB itself is written on C language and C++, and it's sort of a mathematical scripting language, which syntax is similar to C++. MATLAB is quite popular nowadays, and it's quite high in the programming language ratings. It's overtaking Go, Swift, Perl, Fortran, and many others. MATLAB is widely used in different fields of engineering and science. It's used in control systems and embedded systems, and it's used in semiconductor industry as well as in automotive industry. And the companies like AMD, Broadcom, and larger chip makers, all of them are using MATLAB in their flow. For instance, MATLAB can be used to model and design a complete communication system, and then to analyze its performance and even to compare it with the measurements. So why MATLAB is so popular? So if you are not a computer engineer and you don't have any coding background, but you need to analyze a large set of data and visualize it, you can do it using MATLAB without really understanding anything about programming. The MATLAB development environment and the debugger are really handy, and the MATLAB code is super easy to follow even if you don't have any coding background. Another cool thing that MATLAB comes together with Simulink, which is a block diagram based environment used for modeling and simulation of complex systems, which makes it even easier to simulate large systems without having any coding skills. So it is definitely worth learning MATLAB and Simulink for hardware engineers and electrical engineers, because it is very likely that in your career you will need to collect a lot of data, analyze a large set of data and visualize it, and for this MATLAB is the tool. The number 2 in my list is C language, and I know you must be astonished right now, and I get it, because C, by the standard of modern tech, it's a pretty old language. It's like a grandfather of all the modern languages like Python, PHP. Yes, it was invented about 50 years ago at Bell Lab, and it remains popular till today. As of today, as of May 2021, C programming language is ranking first, moving up from the second position which it took last year. Nowadays, C programming language is the most popular programming language among all, and I know it is surprising. Most of the modern system software are written on C. For instance, operating systems such as Windows and Linux. C is widely used to program hardware. It's used to program microcontrollers, which are embedded in everything starting from toasters to medical devices to automobiles. All of these devices are programmed in C. Furthermore, C is the language of choice for embedded systems and firmware programming. C has an advantage because it allows you to develop firmware with limited resources. For instance, when a microcontroller has a very small RAM. Glassdoor lists thousands of jobs in the fields of embedded systems, testing, firmware development, and others which require C programming skills. C programming language is an excellent tool to have in your toolbox as a hardware engineer or as an electrical engineer. And if you're into programming hardware such as microcontrollers or embedded systems, you need C knowledge, so there is no way out. Finally, the number one in my list is Python, and there are many reasons for that. Python is the successor to B and C programming languages, and it is a little bit older than me. It was created back in 1991. Python was selected the language of the year in 2018 and in 2020, and right now it's ranking second right after his father C. Companies which widely use Python includes Google, Amazon, and Facebook. Also, Instagram and Reddit are fully written on Python. Python is used in the wide variety of applications, including emerging fields such as IoT, artificial intelligence, quantum computing, and data science. That's all great, but you might be wondering how Python is related to hardware engineering and electrical engineering. The main use of Python lies in automating routine tasks which we perform daily. For instance, it may include opening a terminal and going to a certain path, then finding a file there, opening the file and parsing some values, then feeding the values into a CSV file and then sending this file to the email. This is one of the classic examples where you can write a single Python script to automate all of these steps. A great learning resource to learn how to do this is a book called Automate Boring Stuff with Python. I highly recommend it. Furthermore, Python is the language of choice for design automation. The most of the EDA, commercial EDA tools are written on Python and support Python IP, which means you can use Python to automate some of the design steps. For instance, using Python, you can automate the generation of full custom layout for some of the analog blocks. Cool stuff! Another interesting add-on here is MyHDL, which is Python-based hardware description language generator. As a result, Python knowledge is often a requirement for hardware engineering jobs and electrical engineering jobs. Moreover, it is a very popular language among startups, so Python knowledge is in high demand right now and will be. Do not, however, learn only one programming language and rely entirely on this language, because no language is the best solution for every task. Sometimes you need just a Unix shell, and sometimes you need to write a small Python script to automate some complex process. Not all the hardware engineering jobs are the same. Different companies, roles, and industries require knowledge of different programming languages, and it's always beneficial to know a couple of them. I hope you learned something new from this video. Let me know in the comments below. And if you enjoyed the video, make sure to give it a like and to subscribe to my channel. And I will see you next week in my next video. Ciao!